Okay, so the first equation, it deals with the total. So cars plus van gives you 44. Second equation can deal with the money, right? The money part. Ethan.
5C plus 8 equals 260.
Perfect. Okay, so $5 per car plus $8 per van equals $262 in total. Okay, looking at these two equations, how many of you did substitution? Okay, how many of you did elimination? Okay, what method did you guys do this? Okay, so yeah, for in this case, both are just as easy. You could do either or, because if you do substitution, you just isolate for one of these variables. If you do elimination, you'll have to multiply the whole equation by either 5 or 8 to eliminate the one of the variables. Okay, number 7. This one was the tricky one. So out of all the examples that you guys did yesterday, the 3 examples, number 7, I would say this is similar to example 3 from your handout. All right, so I have this set up. Oh, so let's see. Andy, can you read example 7 for us? Question 7.
Roads 10 kilometers downstream in 2 hours. On the return trip, it takes him 4 hours to travel 8 kilometers. Determine his average rowing speed and the speed of the current.
Right. Okay. So, how many of you have been on a boat before? Okay. When you're going downstream, do you go faster or slower? Faster, because there's the speed of the current. When you go with the current, it's faster. And then when you go upstream, slower, right? So I have this set up as a chart. So distance, time, and speed, because when we were going downstream, our speed is faster, so it's your speed plus the speed of the current. Right? And then for the upstream, it's going to be your speed minus the speed of the current, because you're going slower. Huh? Yes? No? Okay, so once we have this table set up, then you can use distance equals time times speed for the formula for distance. Okay, so distance, so as we said, distance equals speed times time. So then we have 2 times s plus c, and then 8 equals 4 times s minus c. Okay, let me cover this up first. Okay. Are there any questions as to how we set this up? Okay, so again, going downstream, it means that we have the help of the current, and so that's why it's your speed is your rowing speed plus the current speed. Right? And then, but when you go upstream, it's going to be your rowing speed minus the current speed, because it's pushing you back. Right? So distance equals speed times time. So that's how I set up my 2 equations. Okay? I'm going to go ahead to solve this one. Okay? So when we distribute that 2 to everything inside the bracket, we get this. And when we distribute the 4 to everything inside the bracket, we get that. Okay. Okay, so which method is the easiest? Who says graphing is the easiest to solve this? Who says substitution is the easiest? Who says elimination? That's right, okay. Elimination is the easiest out of the 3 in this case. And that's because all I have to do is multiply everything by 2, and I have the coefficient matching. Alright, so Leandro, choose a letter, S or C?
C.
C. Okay, so let's say I want to eliminate the C's. Should I add or subtract the equations then? Add, that's right.
So 4C. Am I right?
Alright, so because 4C plus negative 4C, that's gone. Alright, so Leandro, 20 plus 8. Okay, and then 4S plus 4S.
Yes.
Yeah, alright. And then now
Divided by
28 divided by 8, which is 28 divided by 8, 3.5. Okay.
why does it have to be a fraction?
In this case, it could be a decimal. On the test, I'll also say what to round to. Alright, what's my unit here?
Your unit is hours.
William?
Kilometers per hour.
Kilometers per hour. Because what is S representing? Speed, right? So this is your rowing speed. So in this case, it's kilometers per hour. Okay, I got S. So I can substitute it in either equation to solve for C. Okay, let's say I substitute it in this one, this right here. So 20 equals 4 times 3.5 plus 4C. 20 equals 4 times 3.5, 14. Move the 14 over, you get 6. And then lastly, divided by 4. 6 divided by 4, 1.5. Okay. So there you go. So therefore, your rowing speed is 3.5 kilometers per hour, and the current speed is 1.5 kilometers per hour. Okay. How many of you got that from the homework? This was from the homework. Okay, good. Will you see a distance, speed, time question on the test?
Hopefully not. Yeah, hopefully not.
Well, I'm telling you, you will. So then you have time to figure that out. Yeah.
Are we supposed to show our work like?
Oh, good question. I'll talk about all that after I take up all the homework questions. There's just a couple more, and then I'll talk about the test. Number 8. So number 8 is very similar. Let's see. Nilia, can you read number 8 for us? Louder, louder.
With a tailwind, the plane flew at 3,000 calories Montreal for 5 hours. The return flight against the wind took 6 hours. Find the wind speed and the speed of the plane.
Okay, perfect. So you see how it's set up exactly the same. You're given distance, you're given time, and you have to figure out the speed of the tailwind and the plane speed. So first equation. So for this one, again, distance equals speed times time. Whoops, sorry. Distance equals speed times time. So in this example here, let me zoom this out a little. Okay, so your first equation would be 3,000. That's the distance equals the time that it took was 5 hours, and with the tailwind. So that means your speed is faster. Okay, I'll put T for tailwind. Okay, so the one before we were rowing a boat, so that's why we use C for current, and then this we'll use T for tailwind. Okay, and then your second equation would be the return trip. So what's the distance? Yeah, right. Also 3,000 because it's the same distance on the return trip. All right, but this time it took 6 hours, and you're going against the wind, so you're subtracting the tailwind. Okay, and there you go. You have the two equations set up. Oh, quick question right here. This is a common mistake that people do. I see the 3,000 and 3,000 right here. Does that mean I should use elimination? No. Okay, you should use substitution elimination based on the coefficient on the variable. The number itself has nothing to do with the method. Yeah. You could, but then if you do that, then you introduce fractions in your equation, and then it will get very messy. Oh, okay, yeah, you could. Yeah, you could divide this by 5, divide this by 6. Yeah, definitely. Okay. But that will only work if like it's nice numbers, because otherwise, again, if it gets into fractions, then it's ugly. Okay. Moving on, number 9. Okay, so 2 more questions from the homework. The milk question. Uh, Tayden, can you read the milk question for us? Number 9.
Milk and cream contain different percents of butter fat. How much 3% milk needs to be mixed with how much 50% cream to give 20 liters of 6% cream?
Okay, thank you. So, what are your two your two types right here? Yeah.
Or two equations?
Variable first. So what are
For X and Y.
don't use X and Y. Use meaningful letters. So what were your X and Y's?
Words you can use.
Of course there is letters. So what are your two types right here? Tayden, you asked about this question. Let's put that phone away. Milk and cream, right? So your two unknown is the milk and the cream. So your M and C. That's right. How much? So remember, the first equation should be the total, right? Read the question again if you need to. So M plus C equals how much? 20 liters, right? So that's right, 20. Right? Good. Second equations deals with the percentage. Okay. So remember I told you guys 99% of the time whenever you see a percent in the question, you have to change it to what? Decimal. Yeah, so 0.03 m plus, yep. Oh, 15 is 0.1. Oh, did you say 15? Oh, sorry. 0.15 what? C, right, for the cream. Equal, okay, what are you trying to make? Yeah, 0.06. Now here's the tricky part. Notice how we set up the equation? Percent times milk, percent times amount, percent times amount. So here on the other side of the equal sign, it should also be percent times the amount, which is 20. Okay. So this is the tricky part to this question. You're making an equation, so the left side should have the same setup as the right side because it's equal. So percent times the milk, percent times the cream, percent times the total. Okay. So then from here, you can the 0.03 m plus 0.15 c equals, when you multiply that together, you can do decimals. So 1.2. Okay. Uh, Looking at this, what method should I use? Gavin? Substitution, right. I would do substitution as well. So isolate one of this and then submit it. In the future, like when you get into grade 11, sometimes another method that's helpful is you can multiply all this by 100 so that you get rid of all the decimals. Right? So you can times everything by 100% so that you get rid of the decimal. So then it becomes 3m plus 15c equals 120. Okay, and then you solve it the same way, and you'll get your answer. Okay, last one right here. Again with the percent. Okay, so now this time we're not talking about milk and cream. What are we talking about here? Granola is made up of nuts and yeah, two different type of nuts, right? Yeah. So instead of milk and cream, it's nuts and nuts. All right. Leandro, can you read number 13 for us?
One type of granola has 30% nuts, by mass. The second type of granola has 50% nuts. What mass of each type needs to be mixed to make 600 grams of granola? I will have 21%.
Okay, thank you. So this first type of nuts, since they're both just nuts, I can't use N and N. So this time let's use X and Y then. Okay, because there's no meaningful letter. Both are just nuts. Okay. So again, your first equation, I'll do it here. First equation deals with the total. Okay, William.
X plus Y equals 600.
Perfect. Okay. There you go. Second equation deals with the percent. Gavin.
0.3 X
Good.
0.15Y
Perfect.
equals 0.21 times 600.
Excellent. Okay, so again, same setup as the milk and cream question. So the key to all these word problems is remember the very first equation is the total. Like 99% of the time, it's the first equation is just the total. Second equation deals with either the percent or the cost or the speed stuff. Okay. Okay. So those were the homework questions.